In Module 4, overall, we've been discussing normal distribution with introduction to normal distribution, examples, and then we derived in Module 3.3 some important relationships, such as the variance of x squared. And we saw how variance of x squared depends on expected value of x to the power 4, and so on. Now, this is a good opportunity for us to introduce software that we will be using for this course for the rest of the semester. In Module 4.4, in the context of normal distribution, I will introduce statistical software. There are two software that we could potentially use, but I would primarily use one of the two because that's much more convenient. And the two are GNU Octave, and that will be our primary software. And the second one is Microsoft Excel. GNU Octave is a full-fledged scientific programming language. It's a free software. It's largely compatible with MATLAB, uses the same function names, and runs many MATLAB scripts without modification, and it's free. It runs on Windows, Mac, and Linux. So it's a great piece of software. It's free, and that's the one that we would be using. I'm going to introduce GNU Octave, and then I'm also going to show you how statistical functions work in Excel. So let me start with GNU Octave. So this is the window that you would have when you run GNU Octave. When you start GNU Octave, this is the window that you're going to see. This is the GUI, graphical user interface, that you will see. And this is the command window. The large one is the command window on the right-hand side. And that's where you'll be typing your commands. And the bottom left shows the command history where all your previously typed commands are stored. And so you can reuse them if need be. And above here is something called workspace, where all your variables are stored. So for instance, I'm going to now define a variable called x. And as with MATLAB, a variable is typically has more than a scalar value. It could be an array. So here I'm going to define an array of values that go between minus 5 in increments of 0.1 to plus 5. So that would give rise to 101 values that you can see here. So when I type the command, I got the 101 values that are stored against the variable x. So you can see now the variable x, and this variable x is class double, meaning it's double position number. It has a dimension of 1 by 101. Okay, it's a row vector with 101 values, and it has values going from minus 5, minus 4.9, and so on. And the command history shows the last command that I typed. And I could type that again, and I would have, it went by quickly, but essentially double-clicking on that particular command reissued the command and defined x once again and overwrote x once again. So now I'm going to define a new variable, mu, corresponding to the mean value to be 0, and sigma corresponding to standard deviation to be equal to, or s corresponding to standard deviation to be equal to 1. So like a standard normal variable. Okay. Maybe I should have, instead of mu, I should have used x bar. I will use x bar instead of mu just to be consistent. So I'll define x bar to have a value of 0. And standard deviation, let me define it as s sub x or sx. and that's equal to value of 1. And if I don't want to see all the clutter on the screen, I type CLC and it clears the screen. Okay, clears the command window. So now I can go ahead and define PDF values. I'm going to define a new variable called nPDF, and nPDF is going to be PDF of all the x values, corresponding to all the x values. So the way, and I want them to be a normal distribution, so I'm going to, the function to do that is called normpdf, and these functions are exactly compatible with MATLAB. So the same command will work exactly as is in MATLAB. So now the normpdf requires 3 arguments. The first argument is the variable x, the values, the variable values at which you want to find the probability density function, the mean value, which is x bar, and the standard deviation, which I defined as s sub x. So I go ahead and do that, and it says I need to load normpdf is part of statistics package. I need to load the statistics package. So therefore, I'm going to now load the statistics package load statistics, and that loaded the statistics package. Now if I want to recall an old command, I use the up arrow, and that can cycle through all the old commands, and down arrow cycles through in the opposite direction. So that's up arrow, down arrow, and so now I have back to the old command. So now I can go ahead and execute that, and now I have values of nPDF, and as you can see on the left hand side, I have 101 nPDF values corresponding to the 101 x values. So now if I want to look to see how this PDF might graph, so I can use a plot command, and plot is x, y. So x value is the variable value, and y is the new quantity that I just defined, nPDF, and I plot that, and that looks like what I would expect for non-PDF, normal distribution PDF. And you can add labels, you can insert text at any point. You can insert text here to say f of x, and I can make this a larger font. So it provides some limited labeling capability, and here I can define a value x, larger font. Okay, and I can also add turn on or turn off the axes. I can turn on or turn off the grid. I'll leave the grid in. So it gives you some limited plotting capabilities. Now I'm going to go back here to my command window. I'm going to close this plot window. I'm going to go back to the command window. So now what I'm going to do is to define normal CDF function, and let me pull the old command back. Now if the PDF is defined by a function called normpdf, we should expect a similar function called normcdf to define the cumulative distribution function. And sure enough, there is a function called normcdf, and that requires 3 arguments as well: the variable, the mean value, and the standard deviation. and I'm going to assign it to a new variable called nCDF. So I go ahead and do that, and I got 101 values. Now if I look at my workspace, I find a new variable nCDF which has 101 values, and that goes as we would expect. The CDF goes between 0 and 1. Now as before, I'm going to plot the CDF. So I recall the old command by pressing the up arrow, and now I'm ready to plot this. And as we would expect, that's what we get, a CDF that goes between 0 and rises to 1. Remember, the property of the CDF is always that it starts at 0 and goes to 1. Okay, so, and again, I can add grid, etc. I can turn on the grid, can turn on auto scale, etc., etc. Okay, so those are very useful commands. There are other commands as well, which we will come back to later on when we do data fitting. I will kind of do a preview one of those commands. And one of those commands is, supposing I have a bunch of values and I want to know if those values correspond to a normal distribution. How well is normal distribution able to describe a bunch of values? One way to do that is something called a norm plot. Norm plot, and it needs only one argument, that's x. And I do that, and I take these x values and I do a norm plot, and we find that these data values can be described reasonably by a normal distribution in a range of values going between 25 here and 75 here, first quartile. Except for the first and last quartile, we find that it's reasonably well described here. So we'll come back to this later on, this norm plot. There's one more thing I want to introduce. If you recall, earlier we did a 3 sigma interval. We calculate a 3 sigma interval using tables, normal distribution tables. Now, when you have a program like Octave, you no longer need normal distribution tables. Tables are handy if you are working with pen and paper. If you have a computer, then you no longer need normal distribution tables. For instance, let's say I want to find the CDF corresponding to a z value of minus 3. So I'm going to call that x lower. Let me call that p lower, corresponding to lower probability limit. So what I want is the CDF corresponding to a z value of minus 3. And since this corresponds to standard normal distribution, the mu value is 0 and standard deviation is 1, which are the values that I've assumed for x bar and s sub x. And I get lower probability value corresponding to a z score of minus 3. I get a value of 0.0013499. Similarly, I can find the probability corresponding to a z value of plus 3, and I'm going to call that p upper. And this value should correspond to what we find in the standard normal distribution table. And that's exactly the value that we had before when we were trying to compute the plus or minus 3 sigma limits in the earlier module. And the upper value is 0.99865. So now I have the lower CDF value corresponding to minus 3, upper CDF value corresponding to plus 3. Now I can find the region between them, probability that x would lie in the region between minus 3 and plus 3, which will be p upper minus p lower, and I do that, and that value turns out to be 0.9973. And that's where one gets the 3 sigma limit, which basically says that 99.73% of the population would lie between plus or minus 3 sigma. And one can similarly do the same sort of calculation for any other limit that you might be interested in. Now, there is also another useful function, and that I would like to introduce. Just as how, given a z value, I can find the CDF, I can do the inverse as well. And that inverse function is norm inverse. And supposing I want to find the norm inverse corresponding to 0.99865, okay, and given x bar and s sub x, I can now find the z value, and the z value turns out to be 3.00, as we would expect. So the norm inverse is again a useful function. This is for inverse lookup of the table. So in other words, given probability, find the z value. Now, some of these functions exist in Excel as well. It's possible to do that in Excel as well, but it is not as convenient as doing it in Octave. Octave allows you to deal with arrays in a nice way, whereas in Excel you would have to define them as columns of numbers and manipulate them. It's a little bit more cumbersome, in my opinion, compared to Octave. So that's the reason why we'll primarily stay with Octave in this course. Now, in practice, when people work in industry, they might use other specialized reliability analysis software, such as Bible++, etc. But those software are specially licensed, whereas Octave is free. And for instructional purposes, for learning the fundamentals, I believe that Octave is a good choice, and that's the reason why I'm using this particular software. Okay, let's go to Excel and see the functions that are available in Excel. So let's say I want to find the PDF, and I've already defined mu here and sigma here. So maybe let me call that x bar, and let me call that s sub x. And so now I want to find the PDF, and I've already defined all the x values here. They go from -5 in the same increment of 0.1 to +5. So I have to now create this column of values. So now I'm going to find the PDF, and the way I would do that is by using this function called norm.distribution, and then you would have to define the x value. The x value here is A7. The mean value here is $B3, and standard deviation is $B4. And the last column, you have two possibilities. If I put true, then I'm seeking the cumulative distribution function. If I type false, then I'm seeking PDF. So that gives me the PDF value corresponding to -5. And I'm going to do the same thing here for CDF, and x is again A7, and mean value is $3 and $4 for the standard deviation, and cumulative in this case is true. So I go ahead and find PDF, And then now I can copy this formula. I can copy these formulae over the entire range. Okay. Okay, not have to see why. Okay, I made a mistake in the formula here in Excel, and the mistake that I made was I put the dollar against B as opposed to dollar against 3, and I should have done here also $4. So instead of keeping the value of mean and standard deviation fixed, I kept the column fixed, and that was my mistake. So I'm going to recopy the formula over. So now I have the values. So now I can go ahead and plot X versus PDF, X versus CDF. I can do that using a scatter plot. So I could go and insert plot, and I would do scatter plot, and I can do scatter with smooth lines. Okay, so I can do that. And so before I do that, I need to select the columns. I need to do X, Y. So I'm going to select these two columns. So now I'm going to insert the plot. And sure enough, that looks like a normal distribution. And I can do the same thing for the CDF as well. And when you plot the CDF, and I'm just going to show you the final result, and this is what it looks like. Normal distribution PDF and normal distribution CDF. So you can do them in Excel as well. But as you can see, it's fairly cumbersome to use Excel to do this sort of statistical function manipulation. It's much easier in Octave. Okay, so I will end our introduction to statistical software there. Before I end, what I would like you to do is to explore the documentation. So as you can notice here in the bottom, there is command window, there is documentation, and editor and variable editor. And GNU Octave has a fairly decent documentation. It's not as extensive as you would find in MATLAB, but it's decent. And specifically, there is this statistics package documentation that you should explore in this class. So you should look to see all the functions that are available. This is fairly easy to go through. In descriptive statistics, for instance, you will find functions for mean, median, mode, etc. Okay. And then similarly, distributions, you'll find basic description. Not all the functions are defined here, but I will introduce the functions that we will need as we go. So please look over the documentation, and maybe you want to even look over the preface and the brief introduction to Octave, etc., etc. So you may want to look over these as well. So with that, I will end module 4.4.